Hi class, welcome to video 1 of Unit 5, Chemical Bonding. In this video, we are going to explain why bonds form and break due to changes in energy. At the end of this video, you should be able to distinguish the three types of bonds and decide which type of bond is formed dependent on the types of atoms involved. Lastly, we are going to classify substances as ionic, covalent, or metallic based on its chemical and physical properties. So the big question is, why do atoms bond? Almost all elements in nature are found in bonded form unless they are noble gases. So why do atoms prefer to be bonded together than alone in their elemental form? The answer is energy. Atoms bond to form lower energy, stable, noble gas, valence electron configurations. Stable situations always have low energy, just like the ground state, while unstable situations have more energy, like the excited state. When a bond is broken, energy is absorbed, and when a bond is formed, energy is released, as the elements have lower energy and more stability. Aside from energy, what makes one atom stick to another? Why does Na love Cl? The answer is electrostatic attraction. When atoms gain or lose electrons to obtain more stable valence electron configurations as they make ions, they will have a charge. Negatively charged species have more electrons than protons, while positively charged species will have less electrons. These two opposite charges will be attracted to one another until they can make a neutral charge, like a noble gas. Here you can see an example of ionic bonding between a sodium atom and a chlorine atom. Sodium is a metal, and it desires to lose electrons as it undergoes oxidation. Chlorine is a nonmetal, and it desires to gain electrons as it undergoes reduction. Chlorine's strong electronegativity pulls sodium's valence electrons towards it. Once electrons are swapped, sodium will have a positive charge, and it will be strongly attracted to chlorine with a negative charge. Notice how the ions both have stable, low energy, valence electron configuration. You already know that atoms gain or lose electrons to form ions in order to obtain stable, noble gas valence electron configuration. But when you look at the noble gases in group 18 on the periodic table, you'll notice that not only do they have electron configurations that typically end in 8, but they also have a total charge of 0. When ions combine to form bonds, it is important to make sure that matter is not created or destroyed, that the number of electrons lost by the metal does not exceed the number of electrons gained by the nonmetal. So the total charge must be 0. Look at the first example, calcium chloride. Calcium has a +2 charge, and it must combine with 2 chlorines of a -1 charge, so that together their total charge is 0. You can see here in the chart to the right a few more examples of how elements will combine in compounds to have a total charge of 0. So again, notice that since barium and oxygen have equal but opposite charge, you only require one of each of them in barium oxide. But since potassium has a +1 charge by losing 1 electron, but sulfur has a -2 charge by gaining 2 electrons, you must have 2 potassiums bond with every one sulfur so that the total charge is 0. Here is some review from Unit 1, where we recall that breaking bonds requires energy. In order to break apart the electrostatically attracted, the positive and negative attracted particles, you'll have to put in energy. The potential energy of the two particles is always greater than the potential energy of the particles together. Recall that potential energy is positional energy, and two separate particles can maintain more positions apart than they can together. Notice that as the potential energy increases, as the positions of the particles increase, their position in the graph is further from the x-axis. It is less stable as these particles have a greater amount of energy to lose. Now, of course, the reverse is also true. Making bonds releases energy. When we form bonds, we decrease the number of positions or decrease the potential energy of the particles. The particles choose to make a bond because of electrostatic attraction. Positive and negative charges come together and take up less positions than they did when they were apart. Notice how, as the bond is formed, the potential energy decreases, and the ending energy seen in the plateau to the right is closer to the x-axis. These particles have less distance to fall. They have lower potential energy, making them more stable. It is important that you're able to distinguish the properties that are associated with the different types of bonds. Find this paper on your note sheet. Pause the video and fill in this sheet. For now, you can use this table to help you distinguish the properties between ionic, covalent, and metallic bonds. But you will have to commit these properties to memory. Now, notice that ionic bonds are also often called salts, and covalent bonds are also called molecular bonds as they form molecules. Molecules only have covalent bonds. And metallic bonds don't actually exist between compounds. They are bonds found between metallic elements when metals bond with themselves. One interesting point to note is that bonds can be determined by the difference of electronegativity. Recall, we can find electronegativity on our reference table, table S. The values that describe the difference of electronegativity vary from book to book. So when in doubt, always examine the type of element in a bond. If there is a metal and a nonmetal, we're dealing with ionic bonds. And two nonmetals is always going to be covalent bonds. The difference of electronegativity helps determine the physical properties that a bond will have. The smaller the difference of electronegativity, the more covalent character a bond will have. So that small differences in electronegativity will have low melting points, low boiling points, and softer textures, while the larger the difference of electronegativity, the more ionic the character, meaning the harder the substance with the higher the boiling point. Here we can see how different types of bonding will contribute to the different physical property or ability to conduct electricity. Ionic bonds only sometimes conduct electricity because in order to conduct electricity, you must have moving charges. Look at the picture of the solid ionic bonded ions. Here, the ions are strongly electrostatically attracted, and they are vibrating in a fixed geometric pattern. These ions cannot move past one another, so they cannot conduct electricity. But when heat is added to turn them into their liquid state, or if they are completely dissolved in water, the ions will be free to move. Free moving ions mean free moving charges, so ionic compounds can conduct electricity. Covalent compounds share electrons. The electrons are shared in such a way that the particles will have a total net charge of 0. Look at the water molecules in red and blue. Notice how there are 2 +1 hydrogens and 1 -1 oxygen. This particle shares electrons and can never separate. Since its charges are not free to move because the particle now has a charge of 0, covalent compounds can never conduct electricity. Metallically bonded elements always conduct electricity. Metals have very low valence numbers, and since we're dealing with the same element, there is no way that the electronegativity of one element can pull on the electrons of another. So instead, metals choose to delocalize their electrons. They spit out their electrons into a sea, as in an ocean. This group of electrons can swim around the metal cations like a Congo line, so at least temporarily all of the metal atoms have a complete valence shell like a stable, low-energy noble gas. Here are the questions you'll have to answer to show your understanding of ionic, covalent, and metallic bonds. In the first question, we are asked to describe covalent bonds. Here, they ask us to describe what is occurring. Recall that all bonds form to obtain stable, noble gas electron configuration. That means choices 2 and 4 that deal with protons can immediately be eliminated. Refer back to the chart so that you can determine what type of atoms form covalent bonds. Question number 2 is a review question. Here, we're talking about a mixture. Recall that in mixtures, there are no new bonds, so there should be no new properties. In choice 3, we are looking for a double covalent bond. Recall that the number of bonds is equal to the number of lone pairs of electrons. Draw out the Lewis dot structures and find the number of lone pairs of electrons. Here, I've drawn the Lewis dot structure of fluorine with its 7 valence electrons. Fluorine only has 1 lone electron, so it only makes 1 bond. Nitrogen has 5 valence electrons, but 1 set of valence electrons are in a pair. Nitrogen makes 3 bonds. Find the element that wants to make 2 bonds, a double bond. In question number 4, we are asked to find what type of bond is formed between the element copper. Copper is element number 29. Question number 5 gives us a description of the physical properties of a compound. Use your chart to answer question number 5. Recall that soft, low melting point substances are called covalent. Find the other word for covalent. In question number 7, we're looking for an ionic bond. Recall that ionic bonds form between metals and nonmetals. Calcium is a metal and oxygen is a nonmetal. We'll use the same technique in question number 8. Question number 9 asks which element is likely to gain electrons. The gain of electrons is likely due to a high electronegativity. Question number 10
again looks for an ionic bond. Recall that ionic bonds are between metals and nonmetals. Question number 11 asks us about what best describes the atom that transfers its valence electrons. To transfer electrons means you give up negative electrons. Metals tend to lose electrons. Find the characteristic that best describes metals. You have now completed video 1 of Unit 5. See you in class.